Hey everybody, Mr. Quick here. Today we're going to be looking at Eureka Math / Engage New York Math, Module 4, Lesson 2, the relationship between multiplication and division. Now, before we jump into it, I want to go over just a couple of very simple math problems, but I want to review how to make a tape diagram in these instances. So let's say we have 8 divided by 2. Well, I'm going to draw this out, a little better than that hopefully, as a tape diagram. And I'm going to create 8 spots, 8 equal sized spots. 1, 2, 3, 4, 5, 6, 7. So we have 1, 2, 3, 4, 5, 6, 7, 8. 8 spots there. If we're going to divide this into 2, we basically have to cut it right down the middle, right? So we're going to divide it right into 2 so there's an equal number on each side. So on this side, there are 4 equal spaces. And on this side, there are 4 equal spaces. So if we take the 8 and divide it into 2, they each equal 4. So we know 8 divided by 2 equals 4. If we, just for instance, were to switch it up and say, let's look at the relationship there going the other way. 8 divided by 4. So we know 8 divided by 2 equals 4. 8 divided by 4 then, let's break that into 4 spots. So this is still 8 altogether. So 1, 2, 3, 4. So we have 4 different spots. And there's, 1, 2 in this location, 1, 2 in this section, 1, 2 in this section, 1, 2 in this section. So 8 divided by 4 equals 2. So you see 8 divided by 2 is 4. 8 divided by 4 is 2. Going backwards, 2 times 4 is 8. 4 times 2 is 8. So you see the relationship there. Let's look at a simple multiplication problem. We'll say 3 times 2. Well, I'm going to do a tape diagram. I'm going to create 3. So this is my 3 right here, right? But if I'm going to do that 2 times, I have to draw another set of 3. So here's my second set of 3. So you see I have 3 2 times, and if you combine those, you end up with 6, right? So 3 times 2 is 6. 2 times 3 is 6. 6 divided by 2 is 3. 6 divided by 3 is 2. You hear my dog freaking out in the background there probably. So you start to see this relationship between multiplication and division. All right, now let's get to the heart of today's lesson. We're going to look at, again, another simple math problem, but it's not about solving the math problem. It's about understanding the concept behind the math problem. So we're going to look at 9 divided by 3. And the first thing I'm going to do here is I'm going to draw a tape diagram to represent my 9. I'm going to draw a little bit better one than that. There we go. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. It always helps to double check that you have the correct amount on there, because one little mistake can give you the wrong answer, right? So I have my 9. This represents 9. So I'm going to show that here. That's 9 spots. Now, if I divide that into 3, essentially I'm going to break it into 3 equal parts. So 1, 2, 3. So we have 1, 2, 3 equal parts. And if I count how many squares are in each section, we have 1, 2, 3. So that gives me 3. 1, 2, 3 gives me 3. Draw that out here. And 1, 2, 3. I have 3 here. So we end up with 9 divided by 3 equals 3. Now, if I were to then multiply that by 3, basically I have my 3 here, right? So my answer was 3. If I was going to multiply that by 3, I'd have to draw that 3 times, which would basically be putting this tape diagram back together to its original state, which would give me 9. So if I wanted to change my original expression here, we have 9 divided by 3 times 3. We had 9, we divided it by 3, then we multiplied that answer by 3. We end up with 9 again, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Point we're trying to show here by using these tape diagrams and looking at all this good stuff, and I'm going to get this kind of out of the way so we can have a little bit more room to write. But the point we're trying to show here is that as we look at this, I hope this looks familiar to you, because essentially you remember that in the first lesson we said, 4 plus 3 minus 3 equals 4, or we said 5 minus 2 plus 2 equals 5. This follows the same pattern. We have an original number, we add 3, we take away 3, so those cancel each other out, and we end up with the original number again. Down here we have the original number 5, we take away 2, we add 2 back in, and we're back to our original number. Well, when it comes to multiplication and division, this is a rule that's obviously very similar in that we start with 9, we divide it into 3 parts, but then we multiply it into 3 parts again, or multiply it by 3, we end up with our original number. And if I asked you to write that as an expression, you might end up with something like this. You might have A divided by B times B equals A again, right? Or an equation. I think I said expression. But essentially what we're looking at is this. When you have a number and you divide it by a number and then multiply it by the same number, you're going to end up in the same place that you left off, right? So A divided by 3, multiply it by 3, basically cancels out, and you're still left with A. Question you may be asking yourself, does it also work if you flip the signs, the multiplication and division sign? Well, let's take a look. Let's do it again with a very simple problem. Let's do 4 times 2. So first I'm going to draw my 4. There's 4 spaces here. I'm going to draw another 4 because I'm doing 4 twice, right? Times 2. So 4 and 4, and all together I have 8. 4 times 2 equals 8. But what if I then divide that by 2? We end up with 8 altogether, right? Divide that into 2 parts. So we have this part here, and we have this part here. Then how many are in each of these parts? 1, 2, 3, 4. 1, 2, 3, 4. So 4 times 2 is 8. 8 divided by 2 is 4, and we're in the same boat. So basically, yes, it does work both ways, depending on which way you put the symbols. So here we may have A divided by B times B equals A. That looks like a 9. Let me change that. And then down here you may have A times B divided by B equals A. Either way, you're basically ending up in the same place, because if you look at divide by B, multiply by B, they're going to cancel out. Times B divided by B, they're going to cancel out, and you end up with A equals A in both cases. Okay, let's go through a couple of quick examples here. All right, we have, in this example, we have 5 times 3 divided by blank equals 5 again. Well, I know times 3 has got to be canceled out by divided by 3 because we end up with the same number. If you solve it, you can figure it out, right? 5 times 3 is 15. 15 divided by 3 is 5. You end up in the same place. 6 divided by blank times 2 equals 6. Well, we start with 6, we end with 6. So if we're going to divide by something and multiply by 2, we have to divide by 2 so they cancel out, right? And you can check this. 6 divided by 2 gives us 3. 3 times 2 gives us 6. So you know you're correct. We're into the variables now, and I actually wanted to show you something here in addition to just the math problem. X divided by y times blank equals x. Well, if we're going to divide by y and multiply by something and end up with x again, it's got to be y. Now, what I wanted to show you, though, is that, I'm going to go ahead and fill in the correct answer here. This problem looks very confusing to me for one main reason. Now, this is the correct answer. This is right. But I have an x here, I have an x here, and it looks like I have an x here. But that's not really an x, that's the multiplication symbol. So what would make this easier would be to change that to the dot, which also means to multiply. Okay, one more example. Blank divided by b times b. Well, if I see division of b, multiplication of b, those two are going to cancel out. If I end at q, I must have started at q. Okay, we'll go over some more examples together in class and look at these concepts. Thank you for watching, and we'll talk to you soon.